So friends, welcome to YouTube channel Tech Guru Gautam Prasad. This is a presentation on brushless DC motor, which is also called BLDC motor. So let's explore what is brushless DC motor. A brushless DC motor also consists of two main parts like other motors, a stator and rotor. Permanent magnets are mounted on the rotor of the BLDC motor and the stator is wound for a specific number of poles, maybe 2 pole, 3 pole, 4 pole, 6 pole, etc. Also, a control circuit is connected to the stator winding, shown on the next page of the presentation. And most of the time, the inverter or the control circuit or controller is integrated with the stator assembly. This is a basic constructional difference between brushless motor and a typical DC motor. So let's proceed. As you can see in this picture, the rotor is rotating and it has got three poles. So these three poles are getting supplies at different times, and that time is controlled by an electronic circuit. So uh, at a time, two poles are getting energized, and the pole permanent magnets on the rotor is making it rotate with the help of these stator poles. Let's proceed. A typical controller circuit provides a three-phase frequency controlled supply to the stator. The supply is controlled by the logical control circuit and energizes a specific stator poles at the specific point in time, as I told you on the last slide. So this is a BLDC motor controller in the ESC circuit. So there are basically IGBTs, three IGBTs, and one rheostat control is there. So this is a speed controller basically, and this supply, the output of the IGBT is going to the stator of the BLDC motor. So here, more complicated picture is there. So as you can see, H1, H2, and H3. These three are Hall effect sensors. So what a Hall effect sensor is there, let's try to understand. So a Hall effect sensor of the BLDC motor operates on the principle of the Hall effect. This was discovered by Edwin Hall in 1879. According to this principle, when the current carrying conductor is placed in a magnetic field, a voltage is generated perpendicular to the direction of the current and magnetic field. So basically, this Hall effect sensor, uh, senses which, where what is the position of the rotor and which poles should be, energized. So this position is essential from the point of view that when a particular stator pole is energized, it basically pulls the rotor poles towards it and makes it rotate. So here is the sensor. Sensor is giving signal to the decoder circuit, and in turn, the decoder circuit is, giving supply or triggering pulse to the IGBTs. So different IGBTs are there, and they are connected to the poles. And this is just a sequence in which these Hall effect Hall effect sensors are, you know, getting the supply from getting the sense signal from the poles of the rotor, and then they are triggering the IGBTs in turn. So this is how this BLDC motor starts working. Let's proceed. So friends, let's try to understand different types of the BLDC motors. So basically there are two types of the BLDC motors based on their construction and design. So the first is inner rotor design and the second is outer rotor design. So regardless of these types, we must note that the permanent magnets are always mounted on the rotor and the winding on the stator. So the first type, inner rotor design, this is also called in runner. In this type of the design, this is basically the conventional type of the design where the rotor is located at the core or the center and the stator winding surrounds it. So as you can see here in the picture, this is the stator and this is the rotor. So in the stator, you have windings on the pole. Basically, this stator has been shown without winding, but the windings are there on the poles, and they are fed with controlled supply. And this rotor rotates at the center as the rotor of the motor. In the second type, that is outer rotor design, this is also called outrunner. So in this configuration, the rotor is external, that is, a stator winding is located at the core or the center, while the rotor carrying the permanent magnet surrounds the stator. So here is the construction. This is basically the stator part, and this is the rotor part. So in the case of the BLDC fan, you have the construction like this, where the outer part is made to rotate. This becomes the rotor. Outer part becomes the rotor, and the inner part is basically the stator. So how does a BLDC motor works? This is $1 million question, and let's try to understand how it works. So a stator winding of the BLDC motor are connected to a control circuit, an integrated switching circuit, or the inverter circuit that we have shown in the picture earlier. The control circuit energizes proper winding at the proper time in the pattern that rotates uh, around the stator. So the permanent magnets on the rotor try to align with the energized electromagnets on the stator, and as soon as it aligns, the next magnets are energized, and thus the rotor keeps running or rotating. The animations on the next page will show you a clear idea how this brushless DC motor works. So here is the picture. As you can see in the picture, this is rotating. The permanent magnets are placed on the outer side, and this is rotating. This is basically outrunner type of the BLDC motor, and this is at the core is the stator, and the outer part, that is the rotor, is rotating. So here this is in runner BLDC motor, in which the rotor is placed in the core or the center, and this is rotating there. And the poles are on the stator. So these poles are fed with the controlled supply, and different poles are energized depending on the supply given to them. So basically, this supply is coming from the DC supply, and they are given to the specific poles at a specific time and in a systematic pattern that makes this rotor rotate at the center. So this is how it works. Now coming to the application of the BLDC motor. So BLDC motors fulfill many types of the requirement that a brushed DC motor does. So, but as they require a complicated controlled circuit, and due to cost considerations, they haven't yet completely replaced the brushed DC motors, especially in low cost applications. So, despite this, there are many applications where BLDC motors are dominating nowadays. The first application comes under the consumer electronics. So computer hard drives apply this type of brushless DC motor, and a small cooling fans like CD and DVD players also use this type of brushless DC motor. And also in the modern applications where the quiet operation without any noise, is desired, such as washing machine, air conditioners, and uh, these brushless DC motors are finding their application in these uh, machines. So electric vehicle is another upcoming area where this brushless DC motor is being utilized. Many electric vehicles, including electric and hybrid cars, electric bikes use BLDC motors. And in the case of consumer electronics, you can also count on the BLDC fans that is getting popular nowadays. They have a wide range of applications in many other areas, including robotics, industrial, motion control systems, etc. So let's talk about the BLDC fans. Basically, BLDC fans are coming into the vogue nowadays because they are running on DC. And in the case of DC, we don't have to consider about the power factor getting worsened with the use of inductive load. So that is a big concern in the case of the inductive loads that it worsens the power factor, and because of worsening of the power factor, the utilization of the power is worsened or deteriorated. So that is the prime concern for which this PLDC fans are getting popular in the market nowadays. So thank you very much for watching this video till the last slide. If you liked the video, don't forget to give a thumbs up. And if you want to ask any question related to this subject, you can ask it in the comment section. I would like to answer your questions as early as possible. If it could be useful for any of your friends, do share this video to your friends. And if you are not subscribed to this channel, I will suggest you to subscribe to this channel for uh, the videos, useful videos like this. So thank you very much once again. Stay tuned with me.